Pretty much it.
No, tell me about each piece.
So, this is my research was done on age and size variation in Cisco. That is a Cisco.
What's
it's
a
fish.
Cisco?
It's a cold water species. It's one of the few cold water species that are native to northern Indiana. Pretty cool looking. So, DNR sampled a bunch of lakes and figured out that Cisco aren't very many lakes anymore. So that's not a good thing because they're being more or less extirpated fairly rapidly.
By what? Or because of what?
Things that they were looking at was that there's eutrophication, which means excess runoff from agricultural fields. And other things are dumping nutrients into the water, and they don't do well with.
Like pesticide poisoning the fish?
No, so fertilizer in water pretty much makes the primary production base get really high. So the plants are gonna grow a lot, and there's gonna be a lot of algae, and then the water's gonna be super dirty and dark. Cisco don't do well in those conditions. So that's one reason.
Why do we need Cisco? Why does Cisco matter?
Because they're a valuable species. As in, they're a species that you should care about because they're really cool fish.
Can we eat them?
You actually can eat them. They taste pretty good.
Do they?
Yes, they do.
Are they fishy fish? Are they flaky fish?
Wait, what are you talking about?
Are they like a mild tasting fish?
I had lake whitefish, which was one of their close cousins. And it was a pretty mild tasting fish, yeah.
Not like super fishy.
Yeah, so some of the graphs here. We're showing that a lot of fish, even with all these different ages, were pretty much all laying in the same length. And we're like, why are all these fish the same size even though they're different ages?
Because they're all on drugs from the agriculture field.
No, that is not correct. So, some of the reasons that we thought was that the sampling method that was used was only getting, the area that was sampled, maybe Cisco the same size just stayed together, and that's just the ones we caught, not necessarily a good average representation of the population, or that they just grew really fast in the first couple years and then just stopped growing. So, and this kind of explains all the calculation methods I ended up doing. Oh, here's a scale, by the way, of a Cisco. So this is what I got told. I got 512 of these. And age about half of them, but yeah, so you can tell.
How do you tell?
So that's a 3-year-old Cisco, because you can see where those dark lines are. That represents pretty much slow growth or the winter. So you can kind of estimate how old a fish is by looking at those third clusters.
Wait, the 3 that you're pointing to, or the really the rigid small guys?
The 3 that I'm pointing to. So you look for those. So
They're
each,
defined
as a
rings.
fish grows, it adds these rings, right, to their body, pretty much adding extra size, more or less. And those really, really, really dark kind of sections is where they grew really slow, because the lines are super compact together. That's why they look darker. You see what I'm saying?
Those are seasons as opposed to the year.
Yeah. So then you can kind of tell how many years they've been pretty much alive.
And that's from its little wing.
That's from a scale. Just a single scale plucked off and magnified. Yeah.
Of the dead Cisco or a live Cisco?
Dead Cisco.
Dead Cisco.
They were sampled and collected. So then the next roundup shows pretty much that they grew this one. Figure 5 is where they grew really fast and then they just stopped growing. So on the y-axis is length, how long they are, and then x-axis is how old they are.
Is that in common of fish? Because I feel like that's true of people.
Yeah, so that's a pretty regular pattern for fish, except it's a little. It should be more of a slope and less of that's pretty unusual to be done growing by that early, because these guys live between probably naturally 6 to 10 years, and they're done growing by 2 or 3 years old. So that's kind of weird if you live until you're 10 years old. So there's that. This is another table.
What's this?
Which one?
That one.
the table shows what age that they were pretty much done growing, and it's obviously a very wide range.
How do you know that?
Huh?
How do you know that they're done growing?
So you can look at the calculation that I used is a growth model one, which is von Bertalanffy. And so, using the length of the fish that you caught, you can more or less get a really good idea of where what their maximum length is going to be, what their maximum growth. And so then that's the age where they are at 95% of that maximum growth that I calculated.
You were catching fish and aiding and abetting in their deaths to do research on them?
It was a DNR, by the way.
But you're worried about this population that you're killing?
No, this was they were collected, let's see, from, actually, were they might have, no, there's no way they would have released those.
You're asking me like I know. This is my research.
I don't.
This is
I only
your
did
poster.
I only did the analysis. I didn't do any of the sampling, so I have no idea what they ended up actually doing with it. But yeah, that was in 2012.
All the scales were caught?
That all the fish were caught. Yeah.
What are these two? In your conclusion?
They might have actually released them. All they did was get. No, they definitely killed them. They got male and female.
Oh my
They
gosh, this
definitely
is
killed
so
them.
unethical. Oh my gosh. This is
So,
terrible.
Let's see. This is, so I back calculated length at age, or size at age for each individual, looking at these scales and pretty much finding a ratio between total length and total scale length. And this figure shows that our growth model is pretty accurate because it lines up with the other back calculated lengths, more or less, for these two legs.
That's these two, showing
Yeah.
how.
So there could be kind of like latent.
So what are your conclusions? What do we do about this?
Conclusions. So
The trees really start to suffer.
they're growing very fast the first couple years of life and then more or less stop growing.
They could be
Compared to other populations that are further north because they're also in Canada and other places.
what you see in the east.
Oh, other populations of this fish.
Yeah, yeah. So we're worried about them being extirpated in Indiana, not necessarily globally, because there's a
Does-
lot of them in Canada.
Do they have like
In
different
Michigan.
farming practices in Canada that might result in differences in their fish being more healthy?
Oh, absolutely. They're cold water species, so they're going to do better in colder water. And with climate change, also.
Maybe they just don't
pushing-
belong down here.
I mean, maybe, depending on what you would
Maybe this is
consider
natural selection at its
anthropogenic
work.
anthropogenic influences as natural selection or not. Yeah. So yeah, rapid growth at an early age is likely what made us catch all the same size with all the different ages. Yeah.
Any other comments?